Use the distributive property to find each product. Use a generic area model to organize your work if needed. I don't know that it's needed for part A, but I think it's useful to kind of look at. So what I'm doing with part A is I notice that I have here a monomial, right? This is something with just one term, right? In the second set of parentheses, there's no addition or subtraction. And then over here I've got a binomial. There are two terms, right? Terms are those things that are separated by addition or subtraction, adding of the opposite. So I'm going to organize this so that I've got a spot for my one-term object. I'll write a 3x along this side of the rectangle. And then across the top I'm going to write a 2x and a 1 because they're two different things, right? I've got a 2x and a 1. Now when I multiply these, this is again, areas of rectangles are obtained by multiplying things. If I multiply 3x by 2x, right? When I multiply those together, I get 3 times 2 is 6, and x times x is x squared. I get 6x squared. And when I multiply the 3x times this 1, right? 3x times 1 is just plain old 3x. And the area of this is those two pieces together. And they're not like terms. I can't write them as one thing. They have to stay separate. But my answer is 6x squared plus 3x, right? That's that one term thing, the monomial times the binomial. Now also, this is our textbook calls this the simplest form of the distributive property, right? I could multiply 3x times 1 and get the 3x, and I can multiply 3x by 2x and get 6x squared. So I can see the answer right there without creating the area model. I just think it's kind of instructive to look at how that works. And also when you go beyond a binomial times a monomial, if you're multiplying like something with 4 terms times 3 terms, this structure really helps. In fact, let's use it for B. So here you can see there are two different terms. One of my terms is x and the other is the constant 2. The next one has two terms also, right? So I've got a 2-term thing times a 2-term thing. So I'm going to make this rectangle, this generic area model that's 2 by 2. And if I go down, I'll put an x and a plus 2. That's the first part of this. And across the other way, I've got a 2x and a plus 1, and that's the second part of this. Now, when I find the area of each of these individual pieces, right, what I'm doing is I'm multiplying the thing that's above it by the thing that's off to the side. So if I multiply x times 2x, that gives me 2 times x, which is 2x squared. Down below that, you can see I'm multiplying a 2 by 2x. A 2 times 2 is a 4, and then it's just the 1x, so this is 4x. Up here I'm multiplying the number 1 by this x in order to get this area inside of here. 1 times x is just plain old x. And then my last box I have 2, and I'm going to multiply that with the number, 1 times 2. So this has a dimension up here of 1 by 2. So this piece has to have an area of 1 times 2, which is 2. Again, multiplying, right? We're finding the area of rectangles. We're not adding. Length times width gives me the area of the parts. Now that I'm done, right, I notice that two of these are like terms. I've got a 4x and I've got an x. I can combine 4x and x into one term. I can call that 5x. 4 of them plus 1 more. Plus 1 more is 5x. Again, I'm adding these parts now to say what the area is. Like I've got this area plus this area plus this area plus this area is all of the areas together. So the answer for this one, we've got a 2x squared, right? And then we've also got 4x plus another x, which is plus 5x. And then finally we've got a 2, so plus a 2. So that's the answer for question 12.